All right, today we're going to be looking at the sine law, and our goals for today are if I can solve for an unknown side using the sine law, or solving for an unknown angle using the sine law. So down below, it says, how would you use the Pythagorean theorem to find the unknown side in the following triangle? So the Pythagorean theorem told us that I had a squared plus b squared is equal to c squared. Now that theorem only works if there is a right angled triangle. In the picture to the left, I have an angle of 120 degrees, which means if I added a right angle, if I added 90 degrees somewhere in this triangle, I would have 210 degrees to work with, which is already too large for a triangle. So in this case, we can't use the Pythagorean theorem. It's a big problem. I can't find the unknown side using all of the things that I know. Okay, if I look down below, how could we possibly use the trigonometric ratios of sine, cosine, and tangent to find the length of the longest side? Now again, with sine, cosine, tangent, we need a 90-degree angle. I don't have one, and I can't get one. 27 degrees is an acute angle, it's less than 90. Angle F, also acute angle, less than 90. Angle D is an obtuse angle, it's bigger than 90. So I can't use the sine, cosine, tangent ratios that I've learned. We can't do it. Okay, there's something else that I have to use, and it's something that is going to be new for a lot of you. Okay, so I have a new law, and that law is called the sine law. And what it tells me is that for any triangle, it could be a right angle triangle, it could be an acute angle triangle, it could be anything. The following fractions and ratios are equal. So what it really says is if I take a side length, I have to divide it by the sine of the opposite angle. And it could be any side of that triangle as long as I divide by the opposite angle. Okay, so you're given it in words as well. Divide a side length by the sine of the angle across from it. Not the one beside it, the one across from it. The number you get will be the same for all three side angle pairs in that triangle. And you're given this relationship in two ways. Okay, you have all the side lengths on the top and the sines of their opposite angles on the bottom, or vice versa. Now we're going to use these ratios in the following examples because it is a lot easier to see how they work when we actually have an example to put them to. So for the very first one, for each triangle, determine the length of side x to the nearest tenth. Now this triangle is not a right angle triangle, so I can't use the Pythagorean theorem. I can't use sine, cosine, and tangent like I've learned them before. Here we have to use the sine law. Okay, and the way we're going to use it is I'm going to say x is the side length we want to find. Now we have to divide it by the sine of its opposite angle, the angle across from it. So we have to take the sine of 42 degrees. If you notice, those are opposite. Okay, now I need another side angle pair. Now in my question, I'm given a side length of 5.4 meters. So I have to divide that by the sine of its opposite angle, which is 78. From here, I have a proportion where I know 3 out of the 4 parts. So what we could do is cross multiply the things that we know, divide by the thing that's left over, and that will take us right to our answer. Okay, so in our calculators, what we're going to do is press 5.4, multiply that by the sine of 42. Now keep in mind your calculator needs to be in degree mode. Okay, and divide that by the sine of 78. And to the nearest tenth, side x is 3.7 meters. Okay, so using the sine law is sometimes a lot easier than using the Pythagorean theorem or sine, cosine, tangent. I don't have to figure out which is the opposite side, the adjacent side, the hypotenuse. I just have to find a side and its opposite angle. So sometimes that can be a lot easier to work with. Okay, we're going to do example B now. Again, trying to find side x, but I don't know side x's opposite angle. Okay, I have to find that angle first. Now you might be wondering how I could do that, but every triangle has a total of 180 degrees. If I know two of the angles, we can subtract the two angles that we know and always find the missing one. So if I take 180 and we subtract 30 and 40, the missing angle is 110 degrees. Okay, and I can absolutely use that to help me. So again, I want to find x. So we have to divide by the sine of its opposite angle. So the sine of 110, that has to be equal to another side angle pair. So the other side length I have is 9.8 meters. So we'll divide that by the sine of its opposite angle, which is 40. Okay, so here's my proportion. Now just like before, cross multiply, divide, and we get our answer. So 9.8 times the sine of 110, enter, divide by the sine of 40, and to the nearest tenth, x is 14.3 meters. Okay, so this one extra step I had to do. I just had to find that angle that I needed to use, but otherwise, very, very similar to the first one. All right, and there are two examples where we'll look at just finding the angle, not the side length this time, but it works in very much the same fashion. Okay, so again, I'm given a triangle, not a right angle triangle, so I do have to use the sine law here. So we're looking for angle x this time. So we're going to say that its opposite side is 7.6 centimeters. So if that's what the side length is, on the bottom, I should have the sine of the opposite angle, which is x. Okay, I need another side angle pair. So the other side angle pair I have is 11.8 centimeters. So I have to divide that by the sine of its opposite angle as well. Okay, my proportion now looks like this. For this example, we actually have an extra step to deal with. So we're going to cross multiply and divide just like before. 7.6 multiply by the sine of 120, divide by 11.8. And it doesn't actually tell me my full answer this time. What it tells me is the sine of x. And that turns out to be 0.55777,90736. Now, in order to finish this question, we have to get rid of sine. Now, just like you learned when you did SOHCAHTOA, what we had to do was not divide by sine, but take the inverse of sine. So whenever you find that button on your calculator, it will give you the sine to the power of -1 with all of the brackets as well. Okay, and what you're going to put inside of those brackets is that very large decimal, or the very long decimal, I should say, that we got from our previous step. Okay, once you put that into your calculator, that angle actually turns out to be 33.9 degrees. Okay, and there's our angle measurement of x. So not very much longer, but there is one additional step that we have to be aware of. Okay, we'll do B as well. Again, looking for angle x. Now this time we're going to write this fraction the opposite way. And what I mean by that is we're going to put the sine of the angle on top this time. Okay. So sine of x goes on top. Its opposite side length goes underneath. Now, if I do that for my first fraction, my second fraction in the sine law, my second side angle pair, should be arranged in the same way. So on the top, I need to place the sine of 43 degrees, and on the bottom should be my opposite side length. Okay, so if we cross multiply and divide, the sine of x is going to be equal to 16.2 times the sine of 43 divided by 12.2. And again, we do get a long decimal, 5,604,379,8. Now keep in mind, again, this is not my final answer. I do have to take the inverse as well. So x is going to be equal to the inverse of sine, okay, with this decimal inside my brackets. Okay, so if you do that on your calculator, take the inverse of that long decimal you found. The angle that we're working with in this case is 64.9 degrees. Okay, so there's how we can use the sine law to help us find some unknowns in a non-right angle triangle, something new. Okay, down below we have our key ideas. So the Pythagorean theorem and the primary trigonometric ratios, so sine, cosine, tangent, can only be used with right angle triangles. Okay, the new thing you learned today, the sine law can be used for any triangle. It could be a right angle triangle, it could be an obtuse triangle, a acute angle triangle, it doesn't matter. It can always, always, always be used. Okay, down below there you have some practice problems. And for those of you without this booklet, I'm just gonna scroll through them and hold for a second so you could pause it, try them out on your own. And the answer key is down below as well. Okay, so if you're going through this, just pause the video, take a few minutes, try out those problems. And you can always double check your work in the end. All right, and there's your answer key to those practice questions. So I hope this helps, and we'll see you next time when we talk about the cosine law.